There are some classes that are known as collections because they act as holders for a number of objects, and they can hold these objects with access and organization in different ways. This program is an example of using a set collection. Now, set is actually an interface, and there are a number of classes that implement this interface, but the one used here is the hash set, which is a simple collection object that contains objects in no particular order. It uses a hash table for storing things internally, but that doesn't matter. The objects are all kept inside the hash set object, and you can come back and get them out in no particular order anytime you want. Now, there are two ways of doing this, and this program demonstrates both of them. First is the simple way of doing things, the way it's been done in Java up until version 5.0 came along. You would put objects inside a general purpose collection object and cast them to whatever type they really are when you want to take them out again. Here, a new hash set object is constructed. The next four statements are calls to the add method of that object. In this example, the objects are all strings, stored as objects. Casting isn't necessary since everything is always an object. The hash set class has a method named iterator, which returns an iterator object. This loop will read the next member of the set as long as the call to hasNext is equal to true. Notice that when an object is taken out of the set's iterator, it has to be cast to the correct type because as far as the set is concerned, everything is an object. If you have to put something in the set that could not be cast to a string, this cast will fail at runtime. There is a way to do it to have the compiler check that you are putting in the right types of objects into the collection and getting the right types out. Here, a new hash set object is being constructed, but this one is being constructed so that the only things that can be put into it are string objects. You can't do this with every class, but there are quite a few defined, so you can do this. The notation's a bit odd. You place the name of the type of the object that it can hold between a less than and a greater than sign and append it this way everywhere you use the name of the class. It becomes a part of the name of the class. The add methods work exactly the same way as they did before, except now they won't accept just any old object. The only thing that they will accept are string objects because that's what you specified when you created the object. Take a look at the documentation of the hash set class, and you'll see where this type name can be added and which methods it will affect. Here you can see that the iterator also needs to be declared with the same sort of thing. It will only retrieve string objects. Again, check the documentation of the iterator, and you'll see where this sort of declaration is an option in the definition. Now, the string objects can be extracted from the set without casting. It's safe. That's because they're guaranteed to be string objects that are coming out because that's the only type of thing that you could put in. You can see that both of the examples work exactly alike. The strings that were put into the set objects are the same ones that came out. Now, these happen to come back in the same order they went in, but that's not guaranteed with this particular class. With a hash organization, no particular order is imposed. With this small number of objects, they come back in the same order, but as the number gets larger, they will get more and more scrambled. There are some collection classes that keep things in order for you, and I'll be showing you that.